definite integral 1. Definite integral 1. Definite integral 1. So indefinite integral, constant. Indefinite integral, indefinite integral, indefinite integral, constant k or c, constant k or c is not added to our result. Constant k or c is not added to our result, since they are given in the data we have in our question. Since they are gotten from the data in the question, since they are given, or since they are given, or you say since they are gotten, since they are gotten from the data in the question, since they are gotten from the data in the question. And now, this definite integral 1 has two types. It has what? Two types. Types of definite integral. Types of definite integral. 1. Problems where x and y are given. Problems where x and y are given to enable us find the value of the constant. Problems where x and y are given to enable us find the value of the constant. Problems where x and y are given to enable us find the value of the constant. Next one is the problem where lower and upper limits are given, thus taking care of the k. Second problem is what? Problems where lower and upper limits are given, thus taking care of the constants k, that is k or c. Now let me explain. Okay, let me give an example first, then I'll explain. Example, let me say the equation of the curve. We say find the equation of the curve which passes through, find the equation of the curve, find the equation of the curve which passes through point 2, 5 at any point of the gradient. At any point of the gradient given by 6x minus 5. Look at this question. I said find the equation of the curve. Find the equation of the curve which passes through the point 2, 5, and whose gradient at any point, and whose gradient at any point, and whose gradient at any point this marker is not right here. And whose gradient at any point is given by 6x minus 5. Now, pay attention, let me explain. This is definite integral 1. In definite integral, constant k or c is not added to our result since they are gotten from the data in the question. What does that mean? Here now, you don't get constant k like we got in indefinite integral 1 and indefinite integral 2 in our final result. But they said because we can get them from the question. And we have two types of definite integral. One is problem where x and y are given to enable us find the value of the constant. That is the one example I'm about to solve now. 2, problems where lower and upper limits are given, thus taking care of the constant k or c. Remember, we have definite integral 1 and we have definite integral 2. Now, let's solve this. Solution. Now, we have this. We now say dy. Let me give you steps. Should I give you steps? Step 1. Introduce dy dx, which is equal to 6x minus 5. Dy dx, which is equal to what? 6x minus 5. So this will be, what you do now is, step 2, you cross multiply. You do what? You cross multiply. When you do that, it will not be dy is equal to 6x minus 5 dx. 6x minus 5 dx. Step 3 is that you introduce integral. You introduce what? You introduce integral. Step 3, you introduce integral. When you do that, you now have integral 6x minus 5. Are you there? It will be what? Integral 6x minus 5. That integral, that is integral 6x minus 5. Or I can also say integral dy into bracket 6x minus 5. When you do that, this is, normal dx. So this will give you integral 6x dx minus integral 5 dx. Now you say applying the formula. That is that formula that was applied in indefinite integral 1. It will now be y is equal to x raised to power n plus 1 over m plus 1 minus s raised to power m plus 1 over m plus 1. So y now is equal to, this is 6x raised to power 1 plus 1 over 1 plus 1 minus 5s raised to power 0 plus 1 over 0 plus 1. So this is y is equal to 6x squared over 2 minus 5s over 1. Now, this will give you y is equal to, this 6 will be divided by 2. You have 3x squared minus 5x plus k plus k plus k or c plus k or c. But we have points here. But you say at point 2, 5, this is x. This marker is not writing well. So at point 2, 5 means that x, this thing means that x, this is x, y. Are you there? Eh? That is to say, but x is equal to 2 and y is equal to 5. Is that correct? Good. So look up here at point 2, 5. That is x is 2 and y is what? 5. That's why I said but x is equal to 2 and y is equal to what? 5. So what do you do? Step 4. Step 4. Step 4. What do you do? Substitute x for 2. So that is y is equal to 3 into bracket. You know, we have 3x. Y is equal to 3x square minus 5x plus k. It's not better I join the step at the same time. Let me do it so that it will be easier. Step 2. Substitute x for 2 and y for 5. Let's do it like that. Step 4. Substitute x for 2 and y for 5. Are you there? Now we have y is equal to 3x squared minus 5x plus k. So here will be 5 equal to 3 into bracket 2 squared minus 5 into bracket 2 plus k. So this is 5 equal to 3 times 4 because 2 squared is 4 minus 5 times 2, 10 plus k. So this is 5 equal to 3 times 4 is 12 minus 10 plus k. 5 equal to 12 minus 10 will give us 2 plus k. Is that correct? So this is 5 minus 2 equal to k. That is to say k is equal to 5 minus 2 and k is equal to what? 3. K is equal to what? 3. So since we've gotten k to be 3, we now say therefore, this marker is not writing well. We now say therefore, or you say hence. You say hence, y is equal to 3x squared minus 5x plus 3. Final answer. Do you understand now? Where did the 3 come from? The k. Remember we said here that problem where value of x and y are given to enable us find the value of what? K. You know, this definite integral 1 is this example. Now this problem 2, which is problem where lower and upper limits are given, thus taking care of the constant k, is for definite integral 2. So this topic now is all about definite integral, and there are 2 types. That is why I purposely wrote definite integral 1 here, so that you know what you are doing. But in the topic, I made it explicit that under definite integral we have 1 and 2. 1 is for the first type and 2 is for the what? Second type. So that is why I'm not going to do anything concerning this, because I said I'm going to handle the video separately. Do you understand now? So we'll leave these two for definite integral 2. I believe you understood this, right? Now we'll talk about definite integral 2.